Hey everyone, how are we doing? Making sure my volume levels are good right there. Tiffany's got a question, then Mohammed's got one. Here we go. Can we do this problem? A forester measured the length of 35 trees. Let's go check it out. That sounds like some chapter 5. Put on a little music. Chapter 5. I want to get some new headphones. I feel like I should just go and order headphones. Maybe I'll just ask my fiance if I can borrow her AirPods. I already stole these headphones from her. She said, why you buy me AirPods if you take my AirPods? It's on chapter 1, part 5. Let's go check this out right here. Let's go. I'm like, yeah, I want those AirPods now. So maybe I don't know. She's fine if I were to take them. I should go grab them real quick. Let's go check out chapter 5, part 1. A forester measured some trees. Let's go check it out. Here we go. Now this is where things get a little bit more difficult. This is the normal curve right here, and probably one of the best websites to go to for us right now is the David M. Lane website. Newbot's going to tell us all about that as he gives you 100 points right here. So the David M. Lane website is where we can kind of draw the normal curve a lot quicker than we can draw it ourselves. So we're going to go right here to the David M. Lane website. We're going to bring it over here to the main page. And we're going to use this to help us out. This is going to be a big help for any question. And I do suggest drawing this. If we go back to what we were doing yesterday, you'll see we were drawing this out by hand. Nothing wrong with using the website, but you also want to know how to draw this out by hand. So it says that the forester measured 30 of the trees. He found they had a mean of this and a standard deviation of this. Now the mean is the center of the curve. So the mean is going to be right here in the center. The standard deviation is going to be how many units we go up each standard deviation, which is just a common length of distance we go up each time. The general normal curve has on it 3 standard deviations. So we should go up 4.2, 4.2, 4.2, down 4.2, down 4.2, down 4.2. That looks accurate. 10.1's at the center. That one does not have 10.1 at the center. This one right here, we go up 4.2, up 4.2, up 4.2, down 4.2, down 4.2, and it looks like I see where the error is at. The empirical rule, which we'll be covering next week, the empirical rule is the 68, 95, 99.7 rule. 68, 95, 99.7. And it needs to go in the order of 68 is in the middle. 68 is between -1 and +1. 95 is within +2, -2. And 99.7 is within +3 and -3. Now, once again, we can use the David M. Lane applet to help us out with this, where we put in these numbers and we get the following answers. Now, this one is using the empirical rules, so if you use this, you will get close answers to the answers, but you need to use the empirical rule here, which is this graphic. So let's go ahead and use this graphic, which is the right graphic, and find out the answers. 1 second. Muted myself and then literally clicked the button. Let's do everybody. Okay, what size would you expect the central 95% of trees to be? So the 95% of trees are within plus or minus how many z-scores? The central 95% of trees, 68, 95. The central 95% of trees are within what? The central 95% of trees are within what? The central 95% of trees are within plus or minus what? Good question right here. The middle 95% of trees are within plus or minus how many standard deviations? This is where we need to know our 68, 95, -2 and +2. Exactly right, Tiffany. Amazing work. Another 50 points. So we're going to go down 2 standard deviations. We're literally just taking 10.1 and going right here and going 10.1 minus 4.2. That's 1 standard deviation minus 4.2 again. And we're down here at 1.7. Same thing when we go up here. It's just telling us the answers. So we can see the answers as we do this. The answers are going to be 1.7 to 18.5 right here. That should be right as long as I can read, which is sometimes an issue. It says right here, what percent of the trees should have diameters over 5.9? Now, this is where it gets tricky. 5.9 is right here. Now, we're going to have to draw this out a little bit. There's a plot from earlier. This is where you want to practice and where a lot of people make mistakes as we go further into the semester. This is where they get a little tricky. What is outside of? People get to these questions on the test, they have no idea how to do them, or they know how to do them very quickly. What is total outside of 68? Like if I have 68% here on the inside, what is total outside of it? If I have 68% on the inside, then what is total outside? Like this right now is 68%. So that's the 68% on the inside. Total outside is what? So this right here is 68%. Then total on the outside would be what? Like 68 inside, 32 outside, and then we're going to cut it in half right here. So I want you to think, what percent of area have I shaded in the curve now? What percent of area have I shaded by shading above 5.9? Very fair test question. There's where 5.9 is at. And what percent of area have I shaded in the curve? So I've put both of these together. We're going above 5.9. We're going like from here over. So above 5.9 is what percent of the curve? Hint, it's everything but 16%. And this is where we just need to practice, and we'll be doing lots of examples like this. So above 5.9 is what percent of the curve? Always try to draw it out. 84, great job, Tiffany. Amazing work, Tiffany. Keep those answers coming because these are really just like test questions. So we found out that that's 84 right there. And we have to memorize the 68, 95, 99.7. This is 84. What percent of trees have between 14.3 and 18.5? So we're going to go right here to our 1,000 graphics open. 14.3 and 18.5, this is a tougher one. We're talking about this right here. Well, let me do it this way. Do you remember we just found this a moment ago? That purple arrow right there, Tiffany, is how much? Do you remember how much we'd cover if we went all the way over on the purple arrow? So if we went all the way through that purple arrow, how much would we cover? We just did this one a moment ago. If you're on this part, check what we just did. Hey, Brian, can you help me on question 402? I think, yeah, we can definitely do it. Yep, Matthew, you bet. We got Muhammad's got a question after this, then we do that one. And Matthew, your question next. You got it. Thank you, Matthew. Great job. What is the total across that area right there? 16. Now here's where it gets tricky. What is the total? I'm going to reshade this again. Now I'm shading 95%. How much is this arrow worth right here? How much is that arrow worth right here? So that arrow right here, think if I've shaded 95% in the center, how much is that arrow worth right here? So the arrow I just drew right here, how much area is that? Because we have 95% in the center. So how much is that worth? You're welcome, Matthew. How much is that purple arrow worth right there? The one I just drew right here. 95 is in the center, and this is symmetric on the outside, so it's got to be half of what's left. 2.5, Tiffany, you're doing a great job. And these are some of the hardest questions. This is where people are like, I have no idea how to work these. So we know this is 2.5% right here. This is going to help us out. This is 2.5%. This is 16% total. What do you notice we need to do? We've got an overlap. So we probably want to take 16 and do what to 16 to find the area inside of here? The area inside of here should be what? Because if we add these, like if we go through it, what do you think we should do if we want to find it? Yeah, let me get that here in a second. You got it. Let me grab that while people think this over. These are the tough questions. These are the ones that like people are like, I have no idea. I keep saying that. Let me go drop the Viz 3 video where I did during office hours. Viz 3 during office hours is on the morning of the 7th. Here it is right here. You get some additional features. There we go. Got it. Yep, I think this is right. Let me double check. That should be it right there. Additional features. Yep, and Tiffany, you are doing it correctly. Tiffany, that's exactly it. 13.5. And just practice solving this. The more you do it, and you might even memorize them, I can tell you all the numbers here are 34, and it repeats 13.5, 2.35, and 0.15. We will cover this in class, but if you do this enough, you will memorize these numbers, and then you can always check your workout. But it repeats on both sides right here. Yeah, awesome job, Chloe, right there. Account services are calling. have no idea what they're calling. So that is 13.5. That's a tricky one right there. Let's go look at this one, over 22.7 inches. So if we go to over 22.7 inches, there's the video link. 22.7 over. Ooh, Tiffany, this is a good one. So now we have that we want this little tiny area right over here. And take a look at this. We know that this area is 99.7. And we want over 22.7. So how are we going to find this right here? If we know that everything Brian is shading is 99.7, because we're doing this area right here, and then we want this little tiny area on the outside, we specifically want this one right here. So the answer is, Tiffany, you are just awesome job today. Another 100 points, Tiffany. You're totally right. It's, we just subtract. I'll show the calculator for those who didn't get it. We take and we find the area outside of 99.7 out of 100. The answer is this is the area outside of, and then we want 1/2 of that because we just want the area over here, just that little area right over there. Great job, Tiffany. That is the answer to that one. You're doing it perfectly. This is the empirical rule, and I think that's got it, unless we did an error. Oh no, what have we done? The area over, between, below. Wait. Oh, there it is. Yep. That's a good way to get caught right there. Be careful. That is the first error of the day. I went above instead of below. That one says below 5.9, which is 16%. Above 5.9 would be 84%. So I was correct when I drew it as above, but the question says below. So don't get tricked right there. See, that's why I'll make 98s on my own tests because I won't read a question properly. So that was, it said below 5.9, and below 5.9 is 16%. Above 5.9 is 84%. So it is true 84% is above, but below is 16%. Tiffany, how are you doing on this question? Does it make more sense? This is using the empirical rule, which tells us the percent of areas between 1, 2, and 3 standard deviations on the normal curve. And then Mohammed wants question 5 for 474. Great work right there. Let's head over. No more mistakes. It's our one mistake of the day. We didn't have a mistake for like a week. Whole week with no mistakes. I mean, we just got to get that mistake out of the way. Got to do it. Got to get in the game. Get those mistakes out of the way. This is 474. I think it's making sense. Good. It's a lot of practice, and that's a hard chapter. Like, that chapter right there is the real deal. That is a tougher chapter. I have so many untitled documents open. Where is the homework? Oh, wait. 2 seconds right here. I'm downloading the homework. Number 5 for 474. Question number 5 for 474. Assignments. Question number 5. Let's see how my graders are doing. I think my grader graded everything. Okay, question number 5. Here we go. Let's go check this out. I'm going to try to do it, but not do it. Let's take a look. Question number 5 for 474. Let's take a look at it. UPS FedEx need to solve the shortest path problem on a daily basis. Given a bunch of locations that a truck must stop at, what is the shortest path for it to take? Calculate the distance along with the path is challenging enough. The following chunk of code defines a matrix like a data frame because it has rows and columns, but to refer to an entry, you have to use square brackets. Makes sense. And numbers before and after the commas. We're looking at matrix position 4, row 4, column 10. Is the entry exactly called distance? This gives the distance between these 2 cities right here, between 15 cities. So when you look at this distance matrix right here, let's go look at the distance matrix. The distance matrix, let me get a little bit bigger so we don't get it scrolling through the screen. You can see right here the distance is, why is there a distance of 0 right here? Think about this. Why is there a distance of 0? Why is there a distance of 0 between city 1 and city 1? So these are the distances between the cities. Why is there a distance of 0 between city 1 and city 1 right here? Why is there a distance of 0? So why is there a distance of 0? So even if you're not in 474, just think about like, okay, this is city 1 and city 1. We have 15 cities like Knoxville, Nashville. And this asks, what is the distance between Knoxville, Knoxville? This is like, what is the difference between Knoxville, Nashville, Knoxville, Chattanooga, Knoxville, Gatlinburg, Knoxville, Memphis, Knoxville, Johnson City, Knoxville, Kingsport, Knoxville, Bristol. I'm running out of cities I know. Knoxville, Farragut. Why does this have a distance of 0? What are we seeing right here? You have to know what you're looking at. Why is it a 0? Why is this a 0? This is, I think we said Chattanooga or Gatlinburg, I said maybe. This is distance from Gatlinburg to Gatlinburg. If you look at the assignment right here and the distance is 0, I'm basically kind of saying it, but why is the distance 0? Why is the distance 0? This is like Chattanooga, Chattanooga. I know they don't have names, but we can just pretend for a moment that it's Chattanooga, Chattanooga, and distance is 0. Why are they distance 0? This is distance between like Johnson City, Johnson City, and the distance is 0. This is distance between like Bristol and Bristol, because it's 5 and 5. Whatever city 5 is. I know you're like, well, that's not Bristol. It's city 5. Whatever city 5 is city 5. And whatever city 5 is down here is city 5. So why is the distance 0 when you look at the distance between Bristol and Bristol? And the answer is because it's the same city. So there's no distance between Kingsport. It's Kingsport, so it's got no distance between it and Kingsport. And so we can see where the larger distances are. Whatever this is something that has a farther distance. 6 and 3 have farther distances from each other. That's just how far is Kingsport from Johnson City. I don't know. Is that about 60 miles? It's more like 20, right? So all this right here is doing the calculations, telling you, explain what's going on, and then define a variable called path length that is initially equal to 0, then uses a for loop, find the total length of the trip by adding up to the values of path length, the distances between the appropriate cities. Print to the screen the values of path length when you are finished. Sanity check is close to 490. So see the strategy below in the R chunk this requires. So this is basically a trip we're doing right here. The trip we're doing is we're going to go from where to where. So where are we starting out at? There is. I knew it. Where are we starting out at? Where are we starting out at here? Look at the path length and tell me where we're starting at. This is like a truck driver here going out for the day, doing a lot of deliveries all day long. What does this path length represent? What does it mean? Remember, we're going to try to talk about our code and say, well, this path length is the trip that they're taking. Right now, we see at the start of the trip, they're doing what? So what does that path length represent right there? Who knows? 50 points in the chat. That path length represents that truck driver is going out and doing what? What are they doing? Remember, we have a matrix of cities down below. We can figure out the distances. Going to come into play in a second right here. And then we have a path that they're taking. So what does that path represent right there? The path is the path they're taking. So this truck driver is starting out in City 1 and driving to City 9. Once they get to City 9, they will drive from City 9 to City 5. Once they get to City 5, they'll drive from 5 to 8, and so on and so on and so on. Finally, the last portion of the trip is going from City 10 to City 11. So kind of important right here, and this is, I'm not going to do too much more. Kind of important right here, we might want to find out first, let's go path length, and assign path length to be equal to 0. And then we probably want to go in here and figure out first, is it M is the matrix? No. What is the matrix called again? It's distance. Distance is the matrix. Probably want to go right here and take their first trip, and that is how long they traveled the first time. You can use 9-1 or 1-9, doesn't matter. It's the same thing because we're either talking about they go from 1 to 9 or 9 to 1. Yeah, Tiffany, let's do that here next. You got it. So they're going from 1 to 9 or 9 to 1. I think we have one more from 320 after this. Matthew's wondering about 320. So Tiffany, yep, after the 321, we'll do that next. You got it. Remember, drop those questions while we're talking right here because then we'll put it in the order and we'll try to remember the order. Sometimes I do them out of order, but I try not to. So this is the distance right here that they're traveling from 1 to 9. what I want to do is I want to take this path length right here and add from the path length the new value of path length right here. And are we supposed to do a running total? No, we're not. Be nice. But this right here is going to add to it the new path length. And now they go from 9 to 5. And guess what? Every time I do this, it's updating. This is starting to look like the what? Wrapped up in every day. Awesome. Some pixie dust. Oh, 100 points right there, Colin. Colin, thank you for swinging by so often. I appreciate that. I miss people swinging by the office hours. I miss us having candy. But Colin, I've lost... I should probably stop losing weight. I've lost like almost 35, 40 pounds since start of the year. I went down from like 205 to like 168 at 6'3". So, but I feel a lot better and I can run a lot better now. Are we supposed to know what the doing for chapter 5? Yes, we not quite yet because we missed the day this week. So some people are working ahead a little bit. Nothing wrong with working ahead. Next week is pretty much all chapter 5 all week long. Big focus on chapter 5, and it's a tough chapter. So you're going to get to see some more of that here in a second, Casey. Great question. You're not really supposed to meant to know. Chapter 5 Canvas content is due on Tuesday. So we will be doing chapter 5 on Tuesday. Keep up those gains. I know, right? It's hard to gain muscle when you're older. I can do 6 pull-ups now, and I'm very proud of that. Very proud. Like when I start out doing my pull-ups, I'm like all the way down, all the way up 6 times. Very proud of that. This right here, I might end this for 474 right here, but that's starting to look like the skeleton. Remember, you don't start by writing your for loop. You start by writing your skeleton. You get the skeleton working, and you need to now think about your placeholders. And it looks to me like we might have 2 separate placeholders. I think you can do it with 1 placeholder. Probably. Just thinking through theoretically. No, you wouldn't want that. Wait. What am I doing? No, there we go. Path. There we go. Be very careful. Making too many changes right here. This is a big help. It's too much help. Path. Yep, that worked. That's working. Halfway through this week's 475. Great job, Ditto. Yep, we got a visualization on number 3. We can go back and do that here in a little bit. We've got a 320 question lined up, a 201 question lined up. And let me grab the Viz 3 video. Here you are right here, Justin. Here's the Viz 3 video, and this is some help for 475. Kind of got the skeleton going, thinking about what we got. That's a huge help for this question right here, so check it out. We're going to go do the 320 question, then some more 201, but put those questions because we only have 2 questions on the list right now. Let's do this. I want to make a section of the screen where it says like upcoming questions. I need to do that. Maybe I'll do that this weekend. I need to put on the board of things to do. But what would people think if when we're doing this, like over on the side, I had a thing that appeared that said like upcoming questions. Like I could maybe make it even slide in and out where it says like upcoming questions, and you could see like, oh, this is coming up right here. And probably just be a Word document that I'm like screen capturing. But it'd be nicer. I'd make it look nice. Like, you ever watch like a TV show where they're like the topics they're talking about are on the side and they're like talking, and then yeah, I'll model it after that, like all those TV shows, like the news shows. Everyone loves news shows. The question is 320. I think it was Matthew asked, "Can you do question 4 for Simon 2 320?" Let's go check that out. Simon 2 320. We got some football tonight. Get ready for some football. Is it Brady? Brady's playing tonight, right? Starting out early. Here we are with assignment 4. Like coming up next? Yeah, exactly. Coming up next, you'd be able to see like what your question is at. So I think that'd be pretty valuable. I might try to make that this weekend. Just sometimes time slips away. Here we are with question 4 for BAS 320, assignment 2. And we see right here that we're trying to do a forecast. Now, with this question right here, it's very important to identify 3 things for a for loop. What are the 3 things we identify for a for loop? What are the 3 things we identify when writing a for loop? The 3 things... I'll give you a hint. What are the 3 things? Tampa Bay... Ooh. think I had Cowboys defense. I dropped him. Variable is 1. Ditto, some 20 points right there. Variable is one of those things. Variable is the placeholder, what changes. Vector is another one of those things. The vector is the values it goes through, and the skeleton is the code that repeats. So we need to identify the variable, the vector, and the skeleton, and so let's go up to here. I'm not going to write the answer, but maybe we'll kind of halfway say the answer. It says fill in elements 4 through 20. Kind of like when we're running this, we'll start by filling in the 4th element. Then we'll start by filling in, we'll do the 5th element next. Great movie. Then we'll do the 6th, the 7th, the 8th, all the way to the 20th element. Kind of sounds like maybe right here we might be talking about the what? Well, that might be, maybe not. Sounds like maybe that is the what. Sounds like maybe when it says we'll be running 4 through 20, when we run this, like filling in element 4, sounds like maybe that's the vector. When we go up to here, whoa, this code kind of looks kind of nice right here. Code kind of looks like maybe this could be used as a what? Like it's got placeholders in it, allegedly. Matthew right there, 20 points. That code looks like it's set up with placeholders in it. It almost looks like it could be run if I just were to go down here. I mean, let's just do this. We go down here and we just go and we take this code. We run the vector n, so we create it. Be very careful. Don't write everything I do. I can't state that enough. Go right here and do that. Boop, boop, boop. Oh, look at that. Oh, look at that. This is what you want to see right here. This is where you're running a for loop, and this is an answer to like other questions because I am running a for loop right now, doing what the for loop does for me. The for loop doesn't do that, but I'm just checking it. But this is what the for loop does for me. And this is the answer to the question. Matthew, how are you looking on this? Because the for loop is going to just keep doing this. I could sit here until, what's it want to go to, 20 or 40? I don't have time to go to, 20. We can do that. So I could go right here and do this. You might have to print the tail or something at the end. But I am literally running your for loop for you. I repeated that. That's not going to end the world. So what do you notice? You should see all portions of where the skeleton is at, where the variable placeholder is at, and what the vector was as I ran this. So you can see the placeholder. You can also see the vector I went through when I was running this. You can see the vector I went through for the placeholder with the skeleton. How's it looking, Matthew? When you run this at the end, you should get the following. There it is. Does it want you to print the tail or the head of the vector? Don't do it that way. You don't want to do it that way. Does it say print the tail or the head? Walk through. Does it say... If you have to print the tail or the head, make sure to do that. The one line of code won't run for me. Don't have any parentheses in it. Make sure, double check you have this right here. Make sure you've also stored the vector n. So make sure you have the vector n. You can find out if vector n is stored by highlighting vector n. I've already appended more to it. But make sure you have the vector n created, or else you can't append to it. Is there a way to go back and watch our previous classes of flying home? So, no, yeah, totally, Katie. Yeah, I won't drop the link in the chat right here, but let me show you that real quick. Matthew, if you're stuck on this one, email me because this is, or Discord me. Katie, which class are you in? 201? Whatever class you're in, Katie. So all my classes will have, some of them have it in a little different of a spot because if you're in 201, go over here to your 201 class and go over here to watch class live. And when you go to watch class live, it'll bring you to the playlist. Yep. So when you go to watch class live right here, I don't click this because it just goes to our class playlist. You will see the class playlist, and in the class playlist, let me show you any sort of class, the 250 class. So yeah, and just go to your class. The 250 class is going to be this one right here. You'll have the one section, and then just go to watch class live. It does say watch class live, but if you click this, you will go to the playlist. So this will bring you to the playlist, which will have all the videos in it. So you can watch any class, you can review. And once again, anytime you're coming back to review, like if we go to the office hours playlist, which we're in the office hours right now, if you go to any previous office hours, no, a lot of office hours, you were live right now. If you go to like yesterday's office hours, awesome, great job. And if you look, it is marked, right? What? Oh, this is the morning office hours. I haven't marked videos from today. I was like, I know I marked yesterday's videos. After a video is live on our class, awesome, great job. After it's live, I go back rather, and mark the videos. So you will see this for yesterday's class video. Still try to watch live. Watching live is the best way to get points, 100 points in the chat, and interact and ask questions. So you can see what we're covering right here. Like we did some Canvas content, and we did all the different things. So you can check it out. Good questions right there. I think we had another question on the list. Was it Tiffany? Was your question next? What question was next? You're welcome, Katie. You're welcome. Thank you. Oh, Brian Inception. It is office hours. Go away, Brian. He's just going to sleep. Let's go check it out. And I think the next question was, let's see here. Casey was wondering about chapter 5. And Tiffany wants can you do this question? Company manufacturing rivets. The rivet. I think so too. If someone had another question, please let us know. I'll try to do them all. And that's what we need to create. It'll just be a thing like over on the side, like saying upcoming questions, and I'll have to make it. We'll make it. Awesome. Let's go check this out. Remember, just throw your questions in here, and we'll try to remember them all. That's our goal. Company making rivets. You cannot start too early on chapter 5. I know it's next week, but I promise. Here's the thing with chapter 5. People do chapter 5 and they say, heard me say this 3 times today. They're just like, I don't know how to do this. They're like, whatever. It's a lot of new stuff. Good to see you here, Reese. Thank you, Reese, for swinging by. 50 points for Reese swinging by right here. So don't let chapter 5 be one of those chapters where you're like, I got no idea. Chapter 5 is going to take some practice. So we're here to practice right now. Here we go with the company that manufactures rivets. Chapter 5, Part 1, Stat 201. A company that manufactures rivets believes that the shear strength in pounds is modeled by a normal distribution. That's what that capital N stands for. With a mean, the first number here is the mean, which means it goes at the center. They're all doing the same thing. And has a standard deviation. This is the variation of 50. Now, here's where people get tricked on this one. This one's a tricky one because you see the distance of 50, but Tiffany, be very careful. This 50 is how many standard deviations above the mean. This is where people get tricked. So this 50 right here is not one standard deviation above the mean. This 50 is what? Because the 68 is 1. So this is not one standard deviation. Because they're trying to trick you with this graphic. This is a mean problem. It's tricked teachers. Probably tricked me once. But I've solved it a lot. This 750 is how many standard deviations above the mean. They're only marking these numbers. They should put 725 right here. This 750 is what? And this curve, let me show you. This curve is a normal curve with a mean of 700 and a standard deviation of 25 because they should mark that. Exactly. And great job, Tiffany. That's exactly, you should be like, oh, that's the standard deviation there is 25. This has caught some students who get A's in the class. Like I've seen A students be like, but that's a distance of 50. And it's like, but it's 2 standard deviations. So we want to look towards a graphic that has, oddly enough, you're like, well, wait, remember, they're just going up 2 standard deviations. So this one is the right answer, and they're just trying to be mean. So that is 2 standard deviations because that's 750, and that's 1 standard deviation. So this has a mean of 700 and a standard deviation of 50, 50, 50. We usually do 3 standard deviations. So this is the correct answer. Would it be safe to use these rivets if they need a shear strength of 650? 650 is going to be a z-score of what? So try to answer this question. This is a good review from yesterday. 650 is going to be a z-score of what? 650 is right here. 650 is a z-score of what? What is the z-score for 650? What is the z-score for 650? -1 exactly. It's 1 standard deviation below the mean because 700 minus 50 is 1 standard deviation below the mean. And then we would see here that how many of the rivets would not meet this? Well, here's a hint. 68% of them would meet it. And then how many would be below it? What percent of rivets would be below this amount? So if 68% is on the inside, it's a repeat question, right, from when we did earlier. If 68% is on the inside, what would be below -1? 68 inside, 32 outside. So what is below -1? The answer is going to be below -1 is what percent? Because we're saying like, okay, 68 is in the middle, 32 is total on the outside, and that makes below 16% below. Yeah, so 16% of the rivets are not going to meet the goal. So no, because 16%, that's the only one that mentions 16%. So no, 16% would have a shear strength less than that. About what percent of rivets can be expected to fall below 800? So below 800, I'll use the same graphic. 800 has a z-score of 2. You can see right here, I didn't mark my 800, but I should have. Oh, I did. It's right there. They marked it for me. 800 has a z-score of 2. And so we could mark 800. And between here and here is 95. So this is where it gets tough. This is a trickier one. I've seen a lot of people miss these ones. What are each of these arrows worth? So I just want to know, like, we have 95 inside, 5 total outside. One of those arrows is worth what alone? Like just one arrow. Just like you say, oh, that arrow's worth this much and this arrow's worth this much. Like if 95's inside, this much is outside. And Tiffany, you got it. Tiffany, 100 points, getting the answers right there. And I'll show it. You are getting it. If anyone's ever stuck on these, let me know. You are solving it along the way because there's 5% total, 2.5 on either side. And then if you go through the arrows right here, which you're doing, you'll see if you add these up, 95 plus 2.5, or you could do 100 minus 2.5, and you would see 97.5, which is pretty much most of the rivets are going to have below that. And that's great work, 97.5 right there. Excellent work, 100. I'd be shocked if we didn't get hundreds. But that's got it. I think we had another question, right? Someone asked another question after this. That's got it. I think we're open questions right now. We got another little bit of time right here. Another like 45 minutes. It's Thursday. It's Haslam Friday. Haslam Friday. Haslam Friday. More time. Go confidence. Yeah. Wonder how my fantasy team's doing. Like, rah. How's my fantasy team doing? Who's played yet? I'm still expected to win in this league. Not that expected totals matter. Ooh, by 0.6. Playing Brady. How am I doing my other league? I'm playing Brady tonight, but watch me. I better not be playing Dallas defense. Packers D. I got Cooper's playing tonight. Amari Cooper. Because it's in Dallas. So a high-scoring game wouldn't be that bad. You got to be a high-scoring game against Brady. And then my other team, Brady right there. And then my other team is... Oh, I only have one questionable now. Saquon Barkley is my only questionable. That's good. Running back might need to switch out. I don't have that strong of running backs. So let's go look at the scoreboard and let's see if there's questions. Well, I'm still winning in this league. Dak Prescott expected to get a lot of points. How can I... Oh, he's my QB. Well, that explains why he's expecting a lot of points. And I got Vikings D, and I got Gronk tonight. Gotta love Gronk. And then CeeDee Lamb. Oh, Dak Prescott's playing tonight. He's for the Cowboys? Okay, cool. I don't care. What's up, Justin? Can we do this one? Which of the following statistics are changed by multiplying each value by a constant? Yeah, let's go check it out. Let's go check it out. Brian checked out his fantasy team. Which of the following are changed by multiplying each value through a constant? Let's do some quickie questions here for Stat 201 and check this out. Here we go. So this is similar to some of the questions being asked. We're going to do some kind of quick questions here. It says shifting data by adding a constant to each of the values. We can actually do this inside of R right here. So let's go right here and make a vector of data. So our vector of data is just going to be 1, 5, 10, 15, and 101. So now let's think about this. If we were to take all these values and add 1,000 to it, think about what we get. Does this make sense? Do you understand this right here, Tiffany? Yeah, ask a 475. You bet, Justin. We're free questions after this. Tiffany, does this make sense? You're seeing the data, and then you're seeing the data plus 1,000. That's what they're talking about by shifting it by adding a constant. So does this make sense right here that we've taken the data and we've added a constant to it? We have right here data's. We ask people, how many pizza slices do you eat in a month? Oh, so I don't know why we'd add 1,000 to this. Someone says I eat 1 pizza slice a month, and someone says, oh, I eat 101 pizza slices a month, and then we just for some reason add 1,000 to it. So now the first person eats 1,001 pizza slices. The next person eats 1,005 pizza slices. These are all just responses to the question of how many pizza slices do you eat? Then we're going to look at this right here. We're going to do a few quickie questions right here. But does this make sense if we ask people, how many pizza slices do you eat a month? And someone said, I eat 1. Another one said, I eat 5, 10, 15, 101. And then we just said, let's add 1,000 to that. So now here's the first answer, but with 1,000 added to it. Does that make sense conceptually? And that's what we're going to look at right here. We're going to look at a few of these. So does this make sense that we've just taken people's answers of how many pizza slices do you eat, and we've added a constant? Does that make sense? We've just said, someone said I eat 1 pizza slice, and we said, let's add 1,000 to that. Awesome. What do you notice about this? The data, does it have a different median? Has the median of the data changed? Yes or no? Has the median of the data changed? And this is a good note to take. We're going to take notes on this and be like, okay, the median of the data, does the median look different? The median is looking different, right? What do you think also changed if you were to take all these and add them up and divide by how many there are? The median and the what have changed right here. Because if you were to add them up and divide by the total, you definitely have a different what. So adding a constant definitely changed the median because the middle number is different now. And it's also going to change the what because if we add them up and divide by the total, we get a totally different number. So it's changed the median. It's also changed the what. The mean's also changed. So the center has changed. Adding a constant has changed the center of the distribution. What has not changed? 1 to 101 is the same range. The IQR right here is 5 to 15, and the IQR right here is the same because it's just the range of the middle 50%. So the range of the data has not changed. The range has not changed. Shifting data by adding a constant each value does not change. And which of these is the only measure of range right here? So shifting data by adding a constant each value does not change the what. Which of these is an only measure of the spread of the data? Not range, spread of the data. Is the quartile a measure of the spread of the data, like the 75th quartile? Now be careful, that's not IQR. We said mean and median did change. So which of these is a measure of spread that would not change? The only one here that's a measure of spread. The IQR does not change. That is correct. And this is quartiles, which is not the IQR. So did the quartiles change, yes or no? Let's look at the data once again. Has the 75th quartile, that's about at the 75th percentile, has that changed? Has the 75th percentile changed when we added values to it? So this is not the IQR right here, but did the quartile change? Not the IQR, but did the quartile change? So when I added 1,000, did that change where the 75th percentile was? And you can see the numbers right there to like confirm, be like, oh, we added 1,000, so would the quartile change? Most definitely. I've got top chat on, live chat. Yes, the quartiles changed. Sorry, I got to remember to change the live chat. I might be a little behind there. It goes to live chat about, I hate that. So the only thing that did not change right here is the standard deviation, which is a measure of spread. If you were to go ahead and we can check this, what's really great is we can go right here. We could just call this Y, and you don't have to know how to code, but we could go here and go standard deviation of X and standard deviation of Y. And remember, we just added 1,000, and you can see that they're the same standard deviation. If you were to do the IQR, which we also said would not change also, you could check your IQRs, and there's your IQRs, which we also see visually is the distance of these numbers, and it does not change when we add a constant. So adding a constant, here's the note to take, would not change the measure of spread of the data, and adding a constant would change the range of the data. And you have a very similar question here. I think yours is multiple choice, but I'm going to try to find yours. Where is it? Too many questions. I like those stereo questions. We're going to find that other question. Oh, here we go. Which of the following statistics are changed by multiplying each data value by a constant? Okay, so can we select multiple things right here? No, we just select one. Okay. So when we multiply something by a constant, let's go look at this. Here we go, and we've got our vector x, and I'm just going to go with vector x and call x multiplied by 1,000. So here is x, here is y. So all I did was multiply it by a constant. Does that make sense right there, Tiffany? Like, I took my values of how many slices of pizza do people eat, and then I multiplied how many slices of pizza they eat by 1,000. So does this make sense right here, what we've done? They're saying, like, if you take your data, which we have for x, and then we multiply it by 1,000 for every value gets multiplied by 1,000, what will change? You know what we can do? We can look at this and just confirm, because it's good to confirm visually right here. Did the median of the data change? Did the median of the data change? Ah, the median did change, right? Now, the mean is the average of all the values. Do you think if you average these up, you'd get a bigger number or a smaller number? So did the mean change? We could go right here and check the mean. Here's the mean of the first set of data. Here's the mean of the second set of data. And you can see the mean is actually bigger by a factor of what we multiplied by. So the mean does change. And that's kind of going to give away what the answers are. Because the mean does change. Does the IQR change? The IQR from here is 5 to 15. That's 10. Here it's 5,000 to 1,500. That's 10,000. Or 15,000. That's 10,000. Does the standard deviation change? There's more spread to this data. So this spread the data out more. It's all the above. Yep. Does it make sense that the data is spread out more? The center of the data is higher. So multiplying by a constant, it won't always make it bigger because you could multiply by like 0.01 or something like that. And now you can see the mean got smaller. When you look at the two vectors, you've decreased the mean right there. So random noises. When you multiply by a constant, you will change all of those right there. Good stuff. Good stuff. I love apartment living. Here we go. Shifting data by adding a constant to each value does not change. I think this is the same question. But adding a constant does not change the what? So it would not change the spread standard deviation. This might have multiple versions. No, it's just one version. Put it on here twice by accident. Fuel economy estimates. I think so. I think we had a 475 question. We'll do the 475, then we'll come back here. Next question. You got it, Tiffany. You have the next question. You have the next question. I'll put on my 80s serious music. Let's go check out the next question. 475, question 5. Don't want to do the full thing here, but let's take a look. So let's go do some reviewing, some 320. If you're in 320, this is a good assignment to check out. Reviewing. Okay, let's take a look at some reviewing, some 320 for 475. Good crossover between classes. Let's go check it out. Question 5 for 475 right here wants us to create a predictive model. Now, we just learned this today in 320, Justin. When you create a model right here, create a model predicting a quantitative y variable from an interaction of a categorical x and a quantitative x in the survey 10 data frame. So we need to show the summary of that model. What do we write to create a model? Tell me the basic format. If I'm going to store into here a model, this is really good. Oh, after that, I guess. Well, I mean, it's kind of showing it right there. The good old days of 320. They just learned this format for the first time today. The old blank, 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 blank. The classic we need to know. The classic, like, basics to building a model. The very classics. Like when we do the formula format with the data. Y tilde, you got, that's where the 100 points, you got it right there. Y tilde x comma data equals. You're like, that's what we always do, right? So y tilde x comma data equals is our common format that we use for the formula. And then after the formula, you tell it where the data frame is in. So you are doing from the survey 10 data frame. I'm not going to use survey 10. I'm going to use survey 9. So the data we use right here is going to be from survey 9. Survey 9, I'm going to go ahead and predict another variable. So create a model predicting a quantitative y variable. Okay, quantitative. So x11, mine auto-completes because I have the attach function on. If you want to autocomplete, you need to do attach. That attaches the vectors to the global environment. Probably just said they, yep. See, they're all masked because I've done it multiple times. So we have that I can autocomplete. That's nice. Quantitative y from an interaction of a categorical x. So here's a categorical x multiplied by another quantitative x. And we want to go here to something else. Quantitative like somebody's weight. There we go. That looks like it's got it. Let me see right here. Survey 9. Egad, what are we doing with Survey 9? Well, you can't use it for yours. If you use Survey 9, you've done the question improperly. So I like to do things outside of what you're doing, but look at what we have right here. We are trying to do what? Just explain to me in words. Once again, we got our rubber ducky right here. I'm going to have my Charmander. 1 second. I was going to try to hold him up, but it's not going to work. I want you to explain to Charmander what this code's doing. Explain to Charmander, and Charmander's going to tell you if he understands it. This is wacky times the Brown right here. Charmander, take your hoodie off. I saw this hoodie for Charmander, and I was like, I want that hoodie. When tells me I got the Charmander. Explain it to Charmander. He does not know what this code does. Charmander, you know what that code does? He's saying no. You want to tell him what you know it does? He doesn't know. That's no in Charmander talk. You have to tell Charmander what that code does over there. Wrong way, Charmander. It's over there. What's that code do? What does that code do? Neither I nor Charmander know what that code does. What the heck does that code do? Charmander, are you confused? I'm sorry, Charmander. No one knows. We're going to be stuck forever not knowing. It's on the right track. I was going to hit the sad music. So you're on the right track. You're on the right track. I'm going to throw you some 50 points. I'll start explaining here in a moment. But I just want you to... Well, so it's storing whatever we're doing, right? So, like, it's storing what we're creating. We're creating something. Charmander's starting to understand right here. Now, this is the what right here. Wait, Charmander, you need to sit over here. You okay, Charmander? You're hitting the mouse, Charmander. Stop that. There we go. Oh my gosh, you pulled up the thing. Charmander, you're about to go away here in a moment again. So we go right here. And this is the y variable. Yep, that's the y variable. And what's this right here? This is a good review of 320. 320, you'll be learning these things. That's the what right there. It's the x. Sorry, I might have zoned out. It's the x1, correct? It's nx, and this is another x. Does that make sense right there? If I do it this way, Charmander, you're gonna have to go away. You learned enough. You learned enough stats for today. It's nx, it's x1, it's x2, and so now what we're saying is, if we look at this in the general form, is we're creating a linear model. So we're going to try to create a line type of equation deal, like y equals mx plus b, where we have an x variable right here interacting with another x variable to explain a y variable. Remember, the x variables explain. We were covering that in 320 today. So the x variables do the explanation of our y variable, and these x variables are contained inside of the data frame over here. You can see them if we go back to where they look. You can see x07 is right here, x03, and we got to bring back that y. x11 is down here. The reason we do this right here, the data, because they're contained in there, and then we're letting them interact to see if somehow one of the x variables might the way in which one x variable explains the y might depend on the other x variable. Because like maybe if someone has a higher weight, then them being in Greek life explains GPA in a different way. That's what we mean by variables that have an interaction. So we're going to store this model such that we can then manipulate it. And there's lots of ways we can manipulate this. First off, now that we have this summary object right here, if we spell summary properly, we can just make a summary of our model nice and instantaneously, and we can find things like p-values. And I am shocked that what? I am actually very, very shocked that what? I am highly shocked. I'm not being sarcastic. I'm actually like, what do you immediately notice about this whole model right here and what's going on? It's interesting. We're trying to understand people's GPA by their weight. Truthfully, it's probably another variable. I'm not going to switch it up because weight's lurking variable's gender. But there's big like everything. This doesn't matter. No one cares about the intercept. Intercept is when everything's equal to 0. P-values are very low, which means, especially when we talk about this right here, the information that these variables bring to the model is significant. The model itself is significant. Here's the significance of the model, telling us that the ability of the model to explain or reduce the sums of squared error in the GPA variable from the naive. That's a little too statty. We try to venture away from that at times. We try just to say, this model gives you a lot of information about someone's GPA. Knowing somebody's Greek life and their weight and the interaction between them would give you information, or you could say is associated with somebody's, yeah, you got it. Let's do some, Cassidy, you got it. We'll do that here next. Or I think we got Tiffany's and Cassidy's question. Thank you, Cassidy, putting that on the list to do. You got it, Cassidy. And so just explaining what this summary means. Did we do any explaining right here? Show the summary. I should have had you explain it a little bit more, but create the visualization. I might do a little bit more parts of this right here. And variance inflation. So I'm going to do a little bit, I know, surprisingly statistically significant, right? We could actually look at the model. That's maybe where I'll end this one. But the visualization right here. Where's my visualization? There we go. Ooh, you know what it might be due to? Ooh. You know what it might be due to? You can see it over here. And actually, this is going to come up in the other thing. Wow, I actually totally stumbled upon something that is a great example of this. It's probably due to that extreme outlier, the person who is in Greek life, who weighs a lot and also has a very low GPA. They're probably the one causing a lot of this. And if we look at the influence plot for it, which I want you to interpret and ask questions, if we look at the influence plot, because they follow the model, they're still pretty influential. There's only 2 influential points, but that person over there, they're surprisingly not influential because they don't have a large deleted studentized residual. They're very close to their line, but yeah, they're not that influential. It's still big, but there's points closer down here that are more influential. The size of the bubble is the size of the influence, which means how strongly they pull the model in their direction, basically. An influential point will change the model, where non-influential points, which are very close to the model, are going to have very small influence. And we're seeing here a lot of calculations like the leverage of a point, which is how far it is away from the mean of the x's. We're seeing here the deleted studentized residual, which is basically just a residual, but turned into t-scores because it's studentized, not standardized. So a lot of concepts right here. A lot of good stuff. I think they're doing repairs outside or something. But this is a good, do you feel like you have a good jumping off point right now, Justin? Good little conversation on this right here. But to talk over these things and to do whichever one you want, you're going to look at the variance inflation. Variance inflation, nice little codes right here. You might want to even look over, ooh, we don't like this. We don't like this. We don't like that. We don't like that. Yeah. This right here. Pretty easy to tell it's 4 because square root of 16 is 4-ish. The way in which, so I'm dropping some hints. The shared variation between the x variables is increasing our uncertainty in our estimates of Greek life by about 4 times, or we have about 4 times the amount of uncertainty due to the shared variation of the x's. Variance inflation is basically standard error squared inflation. So we square root it to take it out of the squared units because variance is standard deviation squared. So we want to know how much our uncertainty in the model, where's our model? Here's our model. And so, which is not that bad because we still have significant coefficients, but Greek life right here has a variance inflation, which is interesting. It's because of the interaction, that's why. Interactions are variables created from other variables, so the interaction itself is going to increase the variance inflation. And so you're seeing basically these two having high variance inflation. Variance inflation is when two variables overlap in what they do, so they bring the same information to the model, and you don't want that. You want your variables to bring unique information to the model. So if your variables bring unique information, they will have low variance inflation. 320 question, what is the lowest variance inflation possible? And it's 1, which would mean no overlap. What's the highest variance inflation possible? It goes to infinity. So because they can be perfectly overlapped, and then it actually is incalculable because you have 100%, talk about mathematical terms, 100% linear dependence in your variables because the variables share the same variation. And think about this, Justin. Would you want to put two variables in the model that do the exact same thing? Would you want to do that? If you have a variable like height, and then you copy that variable and get height 2, which we can do this very quickly by showing this, would you want to put like weight? And here, let's go here to survey 9. And let's go to survey 9 and put into survey 9 weight 2. And we'll just take survey 9 weight 1 and store into it that. And then we have a weight 2. And now we're just going to make a model. Don't do this. We're going to make a model right here. That would be no fun. I agree. Sad times. This is a sad model right here, and you actually can't even tell you because it can't even use it. It's like, no, this does not apply. It's missing. And when we run the variance inflation on it, I think we should get infinity, or it might give like a mad thing. Yeah, it says like they're aliased. Since they're aliased, it can't do it. If I were to, I could make it not aliased pretty quickly by going here and going to weight 2 and making it so it's not perfect. And now it's not perfect. Good. And since it's not perfect, they're almost identical in what they do because I just changed one of the numbers. And we should get a variance inflation that's ridiculous. And this variance inflation right here means that they're bringing nearly identical sources of information. And we have so much more uncertainty because of this, because the model's like, I don't know what to use because they're basically the same thing. So the mathematics is actually talking to us right here and saying, what are you doing? Give me different things. Don't give me Papa John's pizza and Domino's pizza. I want some Papa John's pizza and some Five Guys. Give me different choices right here. Don't give me weight and weight 2, where weight 2 is basically weight 1, but just with a recoded variable. Is this making some more sense here, Justin? I think we're going to do Tiffany's question next. I think there was another one people wanted, or Tiffany's got the next one. But has this helped right here? I hope. I don't want to give away all the answers. Kind of a little talk through of this one right here. So good talk through of number 5. There's a little bit other, but see where you get, and especially email me and put it on the Discord too if you're stuck. We'll be answering as many questions as we can, trying to like help out and get that 320 brain starting rolling again. With that, I think we're gonna head back over here. Awesome, good start to the question. Yep. So make your model, make your visualizations, make your VIFs, and this is like the easy parts of coding, which is nice because we can just go down here and run VIF or summary or visualize. If you look at all these right here, it's just manipulating the model M. We can make a summary of the model. We can make find the variance inflation of the model. We can find these, and you can even do things. It's mad about the plot, but you can do all these things pretty quickly and pretty easily by just running these. There's the visualize because we changed what the variables were, so different stuff. Let's go check this out. Next question is the fuel economy. I think it's the next one we got right here. So remember, this is open questions after this. So open questions. So Justin, if you got another one, if you want to go back and say, can we do a little more of that? Let's go check it out. I got 25 more minutes. So open questions after this one. The fuel economy question for 201. Fuel economy question. Got it. Let's do this. So once again, we're doing chapter 5, stat 201, fuel economy question. And you notice we have the normal curve right here. This is the empirical rule with 68, 95, 99.7, telling us the percent of areas contained within 1, 2, 3 standard deviations. So you always want to make sure when you look at these graphics, it goes 68, 95, 99.7. Know those numbers. We also want to see if the standard deviations are properly aligned such that we have the mean at the center and then we go up 1, 2, 3 standard deviations. So this distance down here needs to be the right amount, which I think that's too small. It says the standard deviation should be 6.2. So if you retake a look at this one, the standard deviation is too small. The mean of the curve should be at 25.8. I'll show you 25.8. That's the center. So they all have 25.8 at the center. And I think this one's the right one because 6.2, if you add, let's show right here. If you were to add 25.8 plus 6.2, you get that. And then we can just keep adding, or we could subtract 6.2 and go down. I'm just going down the numbers. So just watch right here as we go down the numbers, and that's what we want to see as we do this. We're just going up or down the numbers in terms of each time we go up, we're going up a standard deviation, or if we go down, we're going down a standard deviation. So this looks to be the right curve right here and has 68, 95, 99.7 in the correct order. So now when we do this, we need to look at, using the information, in what interval would we expect the central 68% of trees to be? 19.6 to 38.2, because that's the middle. Ooh, yep, no, to 32. Be very careful. It's easy to make errors. The middle 68 is plus or minus 1 standard deviation. So if you didn't have this graphic, you would want to take the mean, 25.8, and add to it 1 standard deviation, and that would be the upper number, or take the mean and subtract from it 1 standard deviation. If you can do math, I can't. 25.8 minus 6.2, and you will get the lower number. What's up, Kiana? Good to see you here. Kiana, 100 points. Everyone swinging by. I've been going crazy with these points. So we are going to put the middle 68%. There we go. About what percent of autos should get more than 32? Kiana, or not Kiana, Tiffany, I know you got this because we've been covering this a lot right here. We remember how we were doing this. It's the same sort of stuff. And this is, if you get these down, you'll be so good on the test. So the middle, or excuse me, we want above 32. So do your drawing. And then think about, we know inside of here is 68%. So we want this shaded area here. We want above 32. So what does that look like? Well, if 68 is inside, then 32 total is outside. Nice job. Yep, you're getting it down. And that means 16% on either side. You know you've done this correctly if you add it up and everything equals 100. So the shaded area I have here in yellow is 16%. So that is, and it's above, right? Because I messed one up last time. Percent should get a more than 32, so it's 16. What percent of autos should get between 32 and 38.2? So 32 and 38.2, these are one of the tougher ones. We just found that 16% right there, so we're going to keep it on the screen. And now let's go and do this. What percent, Tiffany, are these arrows worth right here? Remember that over here is 95. So then if we're looking at one of these arrows now, it's the outside. So remember, 95% is on the inside, 95% on the inside, 5% on the outside. Each one of those arrows is worth what? 2.5. Great job, Tiffany. You got this. And then what we're going to do is we're actually going to subtract that off the 16. So if you were to take this off of the 16, that would leave here 13.5. Notice how if we add across this, we do get 16. If you add those numbers, 13.5 plus 2.5, you get 16, which is the total. So it tells you that you're just like taking off that 2.5 right there to get the 13.5. And that's got this one right here. Describe the best gas mileage of the best 2.5% of cars. The best 2.5% of cars, we actually have it drawn out still, is at the 38.2. So it's right over here. It's a little hard to see with my drawing. So that's the best 2.5% of cars, because this is the upper 2.5%. So there we go. The best 2.5% of cars have a gas mileage of at least 38.2. Mine says worst, then it's going to be the other side of the graphic, the other side. Does that make sense, Tiffany? Right there, if it says the worst, it's going to be the other side of the graphic. Did we just do it? Please tell me I didn't get one other run wrong. Yes. I don't want to make any more mistakes today. If yours says the worst 2.5% of cars, then you're going to the other side of the graphic, which would be down here because this would be the lowest, the bottom 2.5%. This is the 97.5th percentile. Percentiles are on the top side of the curve. Tiffany, what do you think about this chapter? Not so bad after doing a few problems in it. This is the chapter, once again, that turns A's into B's and B's into C's on this test. So people need to start early on this, practice it, and if you're getting questions wrong, then remember, the tests will be harder than the quizzes. You get to ask questions on the quizzes. You get to work as many as you want. You get multiple attempts. And so if you can't do the My Pearson quiz, then that's not good for the test. But don't worry, just ask. Just be like, hey, Brian, how do we do this problem? And then we'll slow it down. We'll figure it out. But I think that's I got a nice job, Tiffany. 100 points in the chat for Tiffany. Yeah. No, that they're tricky. I got one wrong. I would have gotten like a 96 or something. I would have had to redo it. I've done these problems tons and tons of times. It's easy to read above or below. It's easy to put a decimal in wrong. Just work it carefully. If you get things wrong, take a look at what you got wrong. Getting a 100 on this one is a great feat. Now make sure to, I know you're going to come to class. Come to class, practice the topics, and when the test comes around, do the homework and also be looking over test questions on this. If you get this down, the 68, 95, 99.7, then you're doing pretty well. That's got it. Let's head back to the main screen. What questions are there? What questions? Big meeting tomorrow. Looking at everything coming up right here. I get so many emails from Cameo. And they try to tempt me. Because they're like, guess what? Discount at Cameo. And I'm like, ooh, who should I get? Legionnaire. Tossing out some emails I don't have to read. Might grab a little lunch a little early today. Might grab... Did you already do... We did some number 5 earlier. How about 4C? Let's do some 4C. Let's do some 4C. Let's do some 4C. We did some number 5, Kiana. Check the video and see if we did enough. Is there no more questions? Can we do... We could swing back. We'll do the 4C right here. And so let's check out some 4C for 475. Here we go. Let's check out some 4C. Ooh, this is good. This is very much like the other problems. So let's go check out 4C for 475. This helps out with the 5 also with question 5. Let's go check it out. Here we go. So this is really good for number 5 also. This one is simple regression versus multiple. The thing is we already have a multiple regression model. So let me put in a chunk. And once again, we say similar but different work. Remember, I try to not do exactly what you're doing, so because I never want people to copy what I'm doing. We're further down in this problem like we've been going through. 5 and 4 are kind of similar. But we have to make predictions for individuals that is an extrapolation of the model. Okay, so let's take a look at this. We have a model right now. And let's go look at our model. Ooh, let's go make our model back the way it was. Okay, we need to change this back to... There we go. Okay. I think we have our model back the way it was. Oh, we don't have the interaction anymore. Okay. This is our model, correct. Okay. So you have to have a model. Make sure you have a model. And now we're going to make predictions for an extrapolation of our model. So let's make an extrapolation for an individual that is an extrapolation. So what is an extrapolation? Let's look at the model first. So I'm going to visualize my model. You might not do that. Remember, it's different but similar work. An extrapolation, this is also in 201, 320. This is in every class. I can't think of when we do it in 474, but doesn't mean it's not in there somewhere. An extrapolation of a model is when we make predictions where... So this is in all your classes. Tiffany, this is chapter 7 for 201. An extrapolation of a model is when what? An extrapolation of a model is when what? So this is for all classes. If you should know what extrapolating is for when we do it for models. An extrapolation of a model is when what? I need coffee. When are we extrapolating? Good question for 201, 320, 475. So someone say, oh, you extrapolated from your model. You extrapolated too far. When we make predictions, great job, Keanu, right there. When we make predictions outside our model, so where would we be? Just give me a value that would be an extrapolation of weight for this model. We can't really extrapolate out of the Greek, not Greek variable because someone is either Greek or not Greek, so we can't extrapolate out of that. It covers all the areas. So we need to extrapolate on someone's weight. Where would we have an extrapolation of someone's weight? So we'd be extrapolating on someone's weight when what? Like, just give me a value. It can be crazy. But notice the scope of the model goes from, might be hard to see, somewhere down here in the 75s, I think. 500 looks to be an extrapolation. Yep. And we could even check by going to a summary of survey. And we could go here to weight. And the max value is 472, which does make Justin right there another 50 points. You are correct, Justin. 500 would be an extrapolation. And this is in 475, I believe. Yeah, I think so. It's in 320. Cora, good to see you here. Feel free to ask some questions. We are extrapolating because we're going to make a prediction for someone who weighs 500 pounds. Now, here's the thing. When you make predictions, we like to call it a data frame right here. And we're going to make a data frame where we have right here somebody's weight is equal to 500. And we're also using, because I'm using a multiple model, let me appear on the screen and say something. I am making a multiple model. You are making a simple model. I have multiple variables in my multiple model. Does that make sense that my multiple model has multiple variables? If you are doing question 4, you are doing a simple model with one variable. I am doing a multiple model. I'm kind of doing question 4 and 5 right here by doing, I'm making prediction variables or prediction variables for a multiple model, but I have a multiple model that has multiple x's, so I need to make a data frame that has multiple x's. If you do not have multiple x's, you will not have multiple x's. Now it's a simple model. If you have time, go over 4B for 474. We might have time. Yeah. I think we can finish off with that because I have class here in 17 minutes. 27 minutes. So we have right here that we're doing a multiple model right here. And so with this multiple model, we're going to go here to the predict function. And the predict function will make predictions for all individuals in our model unless we tell it another argument called new data. Now, what this is going to do is is just going to make a prediction for that individual. This is the predicted what of this individual. Just look at the graphic and just interpret. Brian used his model, which is just a statistical model with lines and points to predict the what of a person who weighs 500 pounds who's in Greek life. Brian used his model to predict the what of a person who is 500 pounds and in Greek life. And we could change this. We could make them 100 pounds. They wouldn't be an extrapolation now. What am I predicting for just doing this right here? Like I can just run predictions. I could say they're not in Greek life. And you see I can just use my model to make predictions and it solves it for me. I don't have to do the mathematics. We'll go back to an extrapolation right here to somebody who's 500 pounds and in Greek life. So this model is making predictions of the what. And just look at the graphic. The graphic's a big help on what it's doing. We are making predictions, and that's the prediction right there for an individual. Because we say use the model. So it says make predictions using my model for an individual who weighs 500 pounds. Their GPA. Great job, Core, right there. Excellent work. 50 points, Core. You got it. But this is just what we call the point prediction or the best estimate. We actually want to do some prediction intervals. That's not a comma. Interval equal prediction. Since we're predicting for one person, we actually, which is kind of crazy, I'm surprised it's this tight right here. I am 95% confident. This is some 201 right now. I am 95% confident the true GPA of this individual would be contained in the interval 0.05 to 2.28. I am 95% confident the true GPA of this individual would be contained in the interval 0.05 to 2.28. It's pretty crazy. Didn't expect the interval to be that tight. I don't know. Let's probably do that far out individual over here. But extrapolations are outside the bounds of the model, and we would not have confidence in this because our model doesn't have data around that to kind of nail it down. So overall, I'm not that even confident in this prediction because it's outside the scope of the model. You shouldn't be doing extrapolations because your model doesn't have data over here. It doesn't have data. And if you don't have data, you don't have knowledge. If you don't have knowledge, what are you telling me? So good stuff right here. Is this making some more sense, Justin and Kiana? This is how to use the predict function. Remember, you're not doing multivariate. You're doing simple predictions, I think, in this one. So it should be one x variable. You don't use the y variables, though, to make predictions. Remember, you use the x variables, the explanatory variables, to make predictions. So you won't put your y variable in the data frame. If you were to run this with something like this, where you just do like this, it's probably going to get mad. And it says, like, found for, it's basically saying it can't find the weight variable. So if you get something like this, it's going to get mad and be like, what are you doing? It needs a weight variable. And so it's actually going to work there if you do that. How are we looking on this one? I think we're going to look at Core's question right here, and we'll probably end with that. But great office hours, everybody. Lots of work. Lots of all different things. I was confused how to make the extrapolate. Yep. Yeah, and that should show it right there. I think that's a really good help. We've covered a lot of the 475, and it's a good review quiz. It's a good review thing. I'm not going to do a quiz this week. I'm going to do a bonus assignment this week, so stay tuned in class. We're going to have a lot of fun in class today, merging Shiny with what we've done. So we're going to try to do some stuff in class today, and I want you to think about what you can do. If you have a little extra time this weekend, you say, time, Who's got time? Let's go check this out. Last question of the day here. We will come back, do some more. Chapter 5. Oof, Chapter 5, Tiffany, is going to be all next week. So, Cora, more specifically, 4B making the subset. You got it, Cora. Last question of the day. Thank you so much, everyone, for swinging by. We're going to try to make a thing that shows which questions are coming up, but no, Cora, perfect time to ask. Can you start Chapter 5? Oh, you bet. Tiffany, definitely. Oh, Chapter 5 is going to be... Next week, we're probably going to see a lot of people in here being like, Chapter 5! Which... It's a tough chapter. Does anyone remember who was in the upper level classes the first time you had to do the normal curve in 201? Chapter 5. The chapter that is the scary chapter. That chapter scares a lot of people. Scares me. Let's take a look right here on 4B. Let's talk a little bit about it. A little bit of time to talk about it right here. Let's do it. I try not to remember. Okay, here we go. At this point, you should have a data frame created. So you want to create your data frame, which we were just kind of doing a second ago. To create a data frame, you want to go data.frame. Now, when you create data frames, what you get is it puts these into columns, and I'm just hitting buttons. So when you create a data frame, this is just showing how to create a data frame. Each argument in a data frame function is going to create the column putting the vector right there. So if you can see, we get the column of 1 through 10 for the first argument. Was that in jump? Some in jump. In each column, those seems forever ago, I know, right? And then we have right here, Keanu, did you have 201? Keanu, you're taking a lot of classes. Yeah, at 320, I know. But yeah, I was wondering, were you in my 201 class? And then we have 11 through 20. It's just putting these into like columns right here. So what I'm going to do right here is I'm going to make my own column. I think right here. Survey 9. Let's do Survey 9. Survey 9. Let's go to the unique values of people's... Unique values of people's GPA. There we go. Whew. I tell you about it. Oh, that's cool. Awesome. Yeah, Terry's great. Let's go here and find out the unique values of people's GPA. I just cracked myself up. And we're going to sort these. So what I'm doing right here by finding the unique values is, it might work better if I show you a smaller variable than this. Doesn't this have a number of... Sure, number of drinks people have at a party. Great way to end class. Someone has 100 drinks at a party. Don't do that. I don't know if they understood the question. But at least one person says, I have 100 drinks at a party. The question was, how many drinks do you have at a party? So people answered the question accordingly. Here is the answers to the question of how many drinks do you have at a party? A wild party. God, a really crazy wild party. A lot of people didn't answer the question. These are NAs, meaning they didn't answer, which they just don't go to parties. That's totally cool. And then we have here the unique values. Look at how NA is part of this. And now we have the sorted vector. And it actually removed out the NA. That's interesting. I didn't know sorting would remove. A trip to the hospital would say that. Maybe they're talking like, maybe they're taking it out of like a droplet. I don't know. People answer questions weirdly. But this is the sorted unique vector. So I'm going to take this right here. I'm going to call this num drinks. You can assign the name of a vector by doing this. Remember, this is just this vector. This crazy long thing right here is this thing right here. I want to find out also the length of this, and this will tell me how many elements are in this. So that's the length of this right here, and then I'm going to call this right here. Oh, here's going to get a little confusing. This is the length, and I'm going to go right here. I'm going to store this as x, easier to manipulate, rep 0 x times. And let's just call this right here AVG GPA, because I'm going to find out the average GPA of these people. So there's the average GPA. Let's look at what we've created, and what do you notice? I am now going to take Viz3. Let me go grab it for you real quick. I'm now going to take and find the average GPA of these individuals. I only got a little bit of time. There you go, Chloe, in the chat. Great question, Chloe. Thank you. 50 points, Chloe, showing up asking. I'm now going to take and find the average GPA of these individuals. Big question. Help me out here. The first thing I want to do when I'm trying to find the average GPA of these people is find only people who have 0 drinks. I want to create a what of those people. I want to find only people who have 0 drinks at a party and get only those people. So I want to take a what of these people right here. I might do this a different way because I've done this a few times. I might do it a different way. I want to take only the people who have 0 drinks at the party. I want to take a subset. Now I'm going to do this a different way today. Now, always you want to look at what you create. So let's go right here and take and go to our sorted unique vector. And what do you notice? This right here breaks. That's not good. We get 0 because that is the first value in the sorted unique vector of how many drinks people have at a party. But what if we do this? If we go to the data frame and we do the following. We say survey 9, and we go in here and we go to these people, and we go to $, or it's going to be way more complicated if I do that. Let's just do the subset. I can do it, but I've explained it this way multiple times, so I'm going to do it this way. Let's subset the data frame, and now let's subset where people's number of drinks at a party is equal to this. Now, the most important thing you want to do when you create something is 1, store it, and then 2, look at it. And there's only a few people, but what do you notice about the drinks these people have at a party? It's on here somewhere, the zeros. Number of classes missed. These people have 0 drinks at a party. If I change this to the next number, then we can go up to the next number of drinks people have at a party. Oh, that's 2. That's right. So we have the next drinks at a party, and we can keep changing this and going up further and further and further and creating a subset. Now, what do we want to do with this subset? So we're running out of time, so I'm going to go a little quickly. Is we want to find out these people's GPAs, but not just their GPA. We want to find out the average GPA for these people. That's a different subset. And we'll put in na.remove equals true just for good measure because we might have some NAs that could hurt us. And there's the average GPA. And then we want to take this and store this into average GPA into position 2, store into. And when we run this right here, we will start to populate our data frame. Whoops. We'll start to populate our data frame with the average GPA of people. Did I not Oh, I didn't change the subset. Oh. And so now we've changed it, and let's take a look. We're starting to populate it. Always make sure you're doing it. So with this right here, we want to now take this and figure out something. We have multiple parts, and I'll probably leave here in a second because I've got 60 minutes. So we now need to figure out the variable. Hint. And the vector. Hint, hint. I'm doing it the easy way. Don't hard code stuff. And we should have our data frame. Wow, that person... I don't know. We do kind of see a trend in this data, but that person who drinks 100 drinks says they have a 4.0 GPA. They may think that, but Core is seeing it right there. We're making the skeleton. And then we're showing that the skeleton works by putting in the placeholder and running the placeholder. So we got it working right here, and this did create a data frame going through right here and doing this. I did this a little bit quickly. I also probably wouldn't, the way I did that last part, or the 21 coding, that's not good to hard code that. You want to go to the length of the sorted unique vector. Ooh, see, look at me putting problems in this code. That's right there. There we go. And that should do it. We could recreate the data frame here, and then we could rerun this, and then we could check the data frame. Yep. That's got it. Oh, Cora. Oh, thank you so much, Cora. Thank you so much. I know we went quickly on this. I'm hoping that helps out a lot. Just the theory behind it. Make your skeleton working. Get it to work on each individual one. Make sure it's populating it. Have it, like, plug in the numbers. Change it to the variables. Make sure it's populating it. Make sure it's creating the subset. Even though I was doing this quickly, I was still trying to check to make sure everything was creating. That's got it. Little hacker man at the end right there. You know how that goes. Here on Stat 201. 475 here in just 14 minutes. See you soon. Ah! Why do I scream so much? I don't know. Puppet Shark, scream for us. The mug's not broken.